हेलो चिल्ड्रन, वेलकम टू टीच टाइगर्स। स्वागत है आप सबका टीच टाइगर्स में एंड दिस इज वामशी, योर केमिस्ट्री मेंटर। तो चिल्ड्रन, वी आर इनटू द लेक्चर नंबर 6 of the aromatic compounds. As usual, before we begin our session, let's have a quick recap on what we have learned in the last class. So guys, we have just finished Friedel-Crafts reactions, both alkylation as well as acylation, right? Now in today's lecture, we will be discussing about intramolecular Friedel-Crafts reactions. What do you mean by that? Intramolecular. Guys, till now, we have seen a benzene reacting with an acid halide or benzene reacting with alkyl halide. Both were from different molecules. But if you have benzene ring attached to an acid halide, or if you have a benzene ring attached to an alkyl halide, then the intermolecular reaction is the Friedel-Crafts reaction within the molecule, right? So we call such reactions where the Friedel-Crafts alkylation and acylation takes place in a single molecule are known as intramolecular, right? So these are no different. In fact, intramolecular reactions result in a 6-member rings. They are found to yield products in good amounts. So is the same thing with the 5-membered ring and 7-membered ring, right? But the yield is particularly good with 6-membered ring. The product form generally contains a 6-membered. That's what I told you. Sometimes the product will be very tricky. You need not get confused. First of all, we will see what is intermolecular. In the sense, if the Friedel-Crafts reaction is carried between two different molecules, we call this as inter. Then we will see what is intramolecular as the reaction is carried within the same molecule, right? Guys, so first of all, let us predict the intermolecular product. From there, I'll show you how intramolecular can be done. So see guys, what I have done. This is the reactant I have given. So this is the benzene I have, and this is the alkyl halide. They are different. Hence, I call this as intermolecular. See the difference. Because it is from different molecules, I call it as intermolecular, and this is the Lewis acid. You have got this alkyl benzene as the product. So we call this as Friedel-Crafts alkylation, right? So how do we proceed the product for the following? Predict is the point. I'll show you the mechanism first of all. See guys, we have got benzene, right? And I have treated it with see what is the 2-chloropentane. Just see 1, 2, 3, 4, 5. 2-chloropentane. That's what I have written. 1, 2, 3, 4, 5. This is what I have. Right? Now I treat it with AlCl3. So I told you the intermediate of Friedel-Crafts alkylation is a carbocation. Now this was, sorry, this is 2-chloropentane was the species. Now can you tell me what is the intermediate here? This proceeds through this intermediate. I'll write here 1, 2, 3, 4, 5. There is a positive charge here. Am I right? Now one point of this, I told you Friedel-Crafts alkyl reaction proceed with carbocation rearrangement. Do you think the rearrangement is possible here? Now, carbide positive charge cannot migrate here because it results in an unstable carbocation primary. It can go here, still it would result in only secondary, as is the same. So, there would not be much a driving force for the intermediate converting into more stable one, because the intermediate itself is secondary and the other possibility is also secondary. So, you don't have any further rearrangements here. So when this carbocation attacks, you are going to get this. See, check it out. So this is the carbon that is bonded. It is bonded to one carbon. This is this, 1, 2, 3, 4, 5. Now when you have a long chain, I'll tell you one trick. Not trick, in fact, it's always better if you proceed like this. What is that? First of all, do not number it because we'll get confused what number, what carbon would get. What I do, I'll generally name this carbon as A, B, C, D, E. So B is bonded to this benzene ring. First I indicate it. Next, it is bonded to C, D, E, and this is A. So you are going to get 2-phenyl pentane. That's what is the product we have got. 2-phenyl pentane. So this is how I have done. No rearrangement I have seen, and I have written the intermediate. That is how I have written. Alright. Now, guys, this particular naming the carbon with some letter will help you to decide the product without any confusion. So this is about intermolecular, right? I'll show you how to go for intramolecular. There is no much difference. Only thing is, I'll tell you. Yes. So see this question here. You see, benzene is attached to this chloroalkane. So you are going to perform Friedel-Crafts alkylation within the molecule. Hence, I call this as within the molecule. We call it as intramolecular. So you have a Friedel-Crafts reaction within the molecule now. Now, how to guess the product? First of all, let us write the intermediate. That's the first thing. Since Friedel-Crafts reaction proceeds through carbocation rearrangement, check whether there is any carbocation rearrangement. Then see for the final product. I haven't given you the product. We'll see how we proceeded, right? How many carbons are there in the side chain? 1, 2, 3, 4, 5. So I'll write here. Check it out. This is the benzene ring I have. Okay. 1, this is 2, this is 3, this is 4, this is 5. So to which atom is the chlorine atom bonded? 1, 2, 3, 4th carbon. That's what I am doing here. 1, 2, 3, 4th carbon. I add this. Now I am adding AlCl3. By now you might have understood how to predict the intermediate in Friedel-Crafts reaction. This chlorine moves out, resulting in the carbocation. So I am just writing the intermediate. This proceeds via intermediate. I have written, right? So this is 1, this is 2, this is 3, this is 4, this is 5. There is a positive charge here. This is the intermediate. Of course, guys, you will have AlCl4 minus would be there, however. Is this point understood? Yes or no? Now see what I do here. Now this carbon, I'll just change the, I would like to remind you one point, that you need not pay much attention on these bonds that I have written, the sequence of the bond. You can write it anyway. See now, even if I do like this, it is same. So if I change the ring here, you need not get confused, because I told you the carbon atom to which this alkyl group will become our number 1 carbon there. Am I right? So this carbon and this carbon, they are one and the same. Don't get confused, right? Say, sir, here there is a double bond, up here you have a double bond down. No, they are one and the same. Is that point clear? Fine. Now, look at the board, guys. Now, what is the next step? This carbocation, which is the intermediate of the Friedel-Crafts alkylation, would attack the benzene ring, resulting in arenium carbocation. So, this positive charge will come and attack this pi bond. What would happen? The pi bond would break, resulting in arenium carbocation. So now who is the attacking species? First of all, let me number it. Let me letter it, not number. Because you'll get confused that this is 1 or 2. Why did you number from here? So to avoid that, I'm just lettering it. Say this is A, this is B, C, this is D, this is E. So this is the B atom which is going to attack this carbon. Right? Now see what I'm doing. This is the arenium carbocation. So we have this and this. Here you are going to get positive and this carbon gets negative, which would be bonded to this B atom, right? So I am writing this is E, this is D, this is C, this is B. B gets bonded to this atom. Yes or no? So to avoid confusion, I'll just write it again. This is A, this is B, this is C, this is D, this is E. E was bonded to benzene ring. E is bonded to benzene ring. B attacks the benzene ring. B has attacked the benzene ring. This is the arenium carbocation. The alkyl halide is present within the molecule. Benzene ring is also here. So we call this as intramolecular. Now the next step, guys, is so simple. What is that? I need not remember you that there is hydrogen on every carbon atom of benzene. Now you will take AlCl4. This is what you have, right? This abstracts the proton. Sir, why? What is the driving force for this? The driving force for this would be the formation of the aromatic ring. So you would be getting this. Check it out. Right? This is what we have. A pi bond here, single bond. Now a pi bond is formed. Clear? Now guys, you see, you have got a 6-membered ring. This is how it looks like. Yes. This is what I have got. Check it out. This hydrogen separates out as H+. Deprotonation. I guess you people remember it. So that is the product. Guys, this is no carbon atom here. Let me remind you, there is no carbon. It has come after I have written it. This is the right. Is this understood? This is the product. So did you understand, guys? See, so the answer is how to predict it. I tell you. Now you see, let's number here A. This is B. This is C. This is D. This is E. First check which carbon atom is going to become positive. Is it A, B, C, D or E? What? Since chlorine is atom bonded to atom B, then this is the atom which is going to get positive charge. Can there be any rearrangement? No. Now when this B attacks this, how many membered ring are you going to get? You would be getting, you would be getting 1, 2, 3, 4, 5. This is the carbon which is going to attack here. 6-membered ring you are going to get. So that is what I have done. So I am writing a 6-membered ring like this. Now if you want to cross check, you can number it E. This is D. This is C. This is B. B bonded to this atom A. Now check it out. B I have numbered and I know that it is going to bear a positive charge because the carbocation is the intermediate. Now I'll bond it to here. Is this point understood? Right? This is what I have got. So this numbering is just for the sake of our convenience. In case you are very much perfect with this prediction of product, then you can directly go for it. Right, guys? Hope you have understood this. Now, please predict the following. What is that I have? Just see what I have written. Now, see here, I'll mix the both two cases. First, I have done intermolecular, then I have done intramolecular. In this particular reaction, you have to perform both. First inter and then intra. That is how I have given. Earlier, in the first case, we have seen intermolecular between different two species. Then we have seen intramolecular within the molecule. Now you see this example, you have both inter as well as intramolecular Friedel-Crafts reactions taking place. This is so simple. Please pause the video and make a try. You'll enjoy solving this problem. It's so interesting. See what do I do? First of all, see what kind of reaction is this. This is alkyl halide and this is AlCl3 and you have a benzene ring. So this is going to be Friedel-Crafts alkylation reaction. How many carbons are there? 1, 2, 3, 4, 5, 6 carbons. That's what I'm doing here. 1, 2, 3, 4, 5, 6. There is chlorine atom present on the second as well as 5th carbon atom. This is what I have done in the first case. And you also have benzene there. Just check it out. Is that point clear? Now see, what do I do? First thing, you are now sure how to write the intermediate of this reaction because you have done so many problems. Now the first thing is try to predict the intermediate and check whether there is any rearrangement because Friedel-Crafts alkylation results in rearrangement of the carbocation. Now this is so simple, but I have been telling you many times, it's always better to letter. I do it. If you are not, so much interested in it, you can follow the normal procedure without it. First, what do you do? I'll just letter it as A, this is B, this is C, this is D, this is E, this is F. Now, there is carbon atom, there is chlorine atom attached to B and E atoms. The first case, let us see AlCl3 removes the chlorine atom from, say, atom B, let us suppose, or you can take atom E also, both are same. Second position I have, so you need not worry about it. So guys, first thing I do is, I am writing the intermediate in the first step. What is the intermediate here? Just check it out. 1, this is 2, this is 3, this is 4, this is 5, this is 6. Right guys? So there is a chlorine atom on second, there is chlorine atom on this fifth carbon also. So I keep this chlorine here. Why? Because if I attach chlorine here, it is, you have a steric hindrance here. That's why I didn't write. So I have a plus charge here. I have removed this chlorine atom and you have got this species. Am I right? So this is the intermediate and it attacks this benzene ring. Am I right? So what is the first step formed? I am directly writing, guys. The carbocation has gone and attacked it. So see, what do I do? I'll just number it for the sake of my this. This is A, B, C, D, E and F. So atom E is bonded, is going to attack this benzene ring and gets attached. Sir, where should I attach? All the carbon atoms are similar. You can attach it anywhere. Shall I attach here on the first carbon? Yes. Can I attach here on this carbon atom? All are the same. So you can attach it anywhere. I'll attach here. So which carbon atom is going to attach at this here? This E atom. So this is the atom E I have represented. E is bonded to F. This is F. We have F here. E bonded to D. D bonded to C. C bonded to B. A. So you can number it here. This is all the sake of this convenience. Now you are sure where to attach chlorine. Where to attach chlorine? It is present on B. So this is atom B. I'll attach chlorine here. Just see what I have done. E is this atom with positive charge. It is going to attack this benzene ring. E is bonded to F. This is DCBA. DCBA. Now what I do? This is not going to stop here. You again treat it with AlCl3. Right? What is the intermediate now? The intermediate now is the chlorine atom gets removed from here. See what I do, how I write the product here. So this is what I have. This is atom E. This is F. E is bonded to D. D is, just a minute. Right? So, right, this is E bonded to F. F, now this is E bonded to D, C, B and A is also there. So just do not get confused, guys. I am repeating this. This is F, this is E, this is D, next is C. B has got positive charge. So I have written it like this. So now atom B is bonded to chlorine. Chlorine combines with AlCl3. What is removed out? AlCl4 minus is removed, right? Now this is the product form. Which atom has got positive charge? Can you clearly see atom B? Atom B. So there would be no confusion atom. First I have removed chlorine from atom E. Then it gets positive charge. It is bonded to carbon. Now I have removed the chlorine atom from atom B. Now it is going to attack. Where does it attack? So I told you 6-membered rings are found to be stable. This goes and attacks this pi bond. Mechanism you people know. So I'll directly write the product. The product would be this. See? First I have written this. Right? This is atom E, our favorite. Then it is D. Then it is C. Then I have B. This is atom B. So B is going to attack this benzene ring, not A. A is outside this. So B goes and attacks. Just see. That is the product. Now I'll tell you trick like I have done in the last class. What is the trick? Not trick. See what do I do? I'll just number it. How did I number it from right to left? See, I have numbered it A, B, C, D, right to left. Same thing I'm doing here. Just see. I'm doing here like this. A, this is B, this is C, this is D, this is E, this is F. First thing, E goes and attacks this benzene ring because when you remove chlorine atom, this carbon atom gets positive charge. So this is the first thing I am going to write. This is the E which is bonded. E, it is bonded. Right? Now this is F. So I have written up. Now how many carbons down after E? 1, 2, 3, 4. 1, 2, 3, 4. Now this is atom B which is going to attack. So just number it. This is A, this is B, this is C, this is D, this is E, this is F. I have written it. E gets bonded to carbon. After that, B gets bonded to this. This is B. That's it. So wherever chlorine is attached, remove it and attach to it. You probably get 6 carbon atom. A, B, C, D, E, F. B and E are attached to chlorine. B and E are attached to chlorine. Remove that and attach to the benzene ring, you will get the product. Very simple. Is that clear? Same we have done in the last case also, if you guys remember. So I'll just see what I have done here. I'll erase all the links. Erase all the links. Fine. So just give numbering to it. A, this is B, this is C, this is D, this is E. Right, over. So who is going to attack? Remove chlorine atom from atom B. B is going to attack. So, right, this is E. Then it is D. Then it is C. Then it is B. Then this is E. B gets attacked. So this seems to be so simple because we have done this so difficult problem. Am I right? Now we feel it so easy. Right? Hope you people have understood this. Intramolecular. Inter is between different. Intra is within the same molecule. So guys, the same we are going to do with Friedel-Crafts acylation. First we have done alkylation, right? Now we'll go for acylation. Same here. First we'll go for inter between different molecules. Then I'll apply the same thing to intramolecular acylation. See, first I have given you a simple this. This is what I have. Right? Same I'm going to give numbering. That is up to you whether this is true. This is a simple acid halide. It is reacting with AlCl3. Benzene react with Acyl halide in the presence of Lewis base to give acyl benzene. Am I right? So first of all, let us write the reaction here. You have got this benzene ring and this carbon. How many carbon atoms are there? 1, 2, 3, 4. So 1, 2, 3, 4. This is double bond O. This is Cl. Am I right? 1, 2, 3, 4 carbon atoms are there. Now what is the first step when you treat it with AlCl3? First write the intermediate. This is not that difficult like you had there. Okay. Now 1, 2, 3. This is the arenium ion that you are going to get. Am I right? C double bond O. If you are get confused, I'll just write it in a different way. Like, see what I do here. This is the first carbon, so I'll write it at CH3. This is CH2. This is CH2. 1, 2, 3, 4th carbon has C double bond O. This is plus. sp hybridized, it has to be linear. But in order to make you people understand, I have written it. Actually, this is sp hybridized, it has to be linear. And there is no rearrangement here. It is resonance stabilized. Arenium carbocation is resonance stabilized. There is no rearrangement. This itself is stable. Now this will go and attack the benzene ring. So directly you can write the product. So this would be the product. This is attached to C double bond O. 1, 2, 3, 1, 2, 3. This is the product. Just check it out. Did I give you the product here? No, that is the product there. Just check. Right? And that is the acyl benzene that we have. Right? So this is how you predict the product. Now see, let's go for different thing. Now predict the product of the following reaction. Here I have given you intramolecular Friedel-Crafts acylation. Benzene you have and acid chloride is present in the same molecule. So we call this as intramolecular. So I told you the same thing. First predict the intermediate. It is so simple. See what do? I have this. See, the product would be very simple once you understand. Only thing is in intramolecular you will be going to get a closed chain. That's it. So how many carbons you have here, guys? 1, 2, 3, 4. That's what I have. Same compound here. 1, 2, 3, 4. This is C double bond O Cl. Alright. In case you have not satisfied with this, I will write like this. This is 1, 2, this is 3, this is 4. Fourth is having C double bond O and this is Cl. Now I treat it with AlCl3. This is for my convenience. I have written this because I know I have to attack this carbon. I have to attack this carbon on this benzene ring. So first write the intermediate, guys. What is the intermediate? The acylium carbocation. How do you write it? This is the benzene ring. You have 6-member ring. This is 1, this is 2, this is 3, this is 4. This is the rhenium carbocation. Am I right? Once you know it, this is going and attacking this. So how many members are way to attack? Shall I write here? See what would happen if you write here. If this carbon attacks here, you would be getting how many membered ring? 1, 2, 3, 4, 5, 6, 7 membered ring. Can it go and attack here? Let us check. 1, 2, 3, 4, 5 membered ring. What if it attacks here? 1, 2, 3, 4, 5, 6. 6 membered rings are stable. So I write the product here like this. Okay, once you have written this, this is this is C double bond O. This will go and attack here. So this is the beautiful product that I have written. So good, I guess. Am I right? Just check it out. First thing, acylation products are generally, easy compared to that. Very simple. First, we have written the carbocation. Acylium carbocation. Then there is no chance for rearrangement. Directly bond it. Sir, where to attack the bond? Wherever you check the member, you can attach anywhere. You can attack here, 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 everywhere. Sir, can I attach here? See, if it attaches here, let us see how many carbons you will have. This is 1, 2, 3, 4, 5, 6. That means this and that would be same. Is that point clear? So you need not worry about it. Just draw 6-membered ring. See that this C double bond O gets attached to the benzene ring. Wherever you feel that it is making 6-membered ring, you go and attack there. Whether you attach here or here, it would be same. Clear, guys? Benzene is a perfect and pure hexagon, right? So now I have this question, guys. What is that? See, what did I give? Oh, cyclic ester I have given. So this is the question for you. Quiz yourself. This was given in your IIT advanced exam. So I just want to quiz yourself. Make it right. This is your homework. This problem I would be doing in the next class and see how many, I would like to check how many people have got it. So simple, a bit mechanism you have to be careful. How do you do it? All these examples have been trying to explain the mechanism so that you can predict, you can guess, you can expect the unexpected one. This is the unexpected one. This is the first time you are seeing such a tricky problem. This would be simple, but still you people have to try. I'll do it in the next lecture number 7. This is lecture number 6. I'll explain this. So this is your quiz yourself. Let us see how many of you will do it. So guys, next interesting thing. What is that interesting? Intramolecular Friedel-Crafts reaction also work for some carboxylic acid. What was this? This is, we call this as cyclic esters, lactones we call. Now you have carboxylic acids can also be used for Friedel-Crafts acylation. Let us see with one example. Let us see this. You have this, the product of the following. You have got this carboxylic acid and I am treating it with the acid. So for your sake of convenience, I have also given letters here A, B, C, D so that it's very easy to predict the answer. Anyways, let us see this beautiful question. So I have this benzene. Oh, this you have. Methoxy group is attached to it. Just check it out. Methoxy group. Right? Now you have A, B, C, D carbons. A, B, C, D, double bond, O, OH. I'll now letter it A, B, this is C, this is D. Only for the sake of convenience, it has got nothing to do. What did I add here? I have added an H plus, not HCl, guys. You have to add H2SO4 or HCPO4 also you can add. You'll learn this later classes. I'm deal with this later. What does H2SO4 do? It releases H plus ion. H plus ion goes and attacks. This is an electrophile. Sir, why doesn't it go and attack the benzene ring? I told you already, the reaction of H plus on this benzene ring is reversible. Of course, any electrophile attack on benzene ring is an reversible. But the reaction is mostly towards this reactant, not towards product. It is totally reversible, but the product is not favorable, only the reaction is favorable to the reactant side. I have already explained this in chlorination and sulfonation also. I have explained this, why sulfonation is reversible. I have explained that. Anyways, I'll come to this. H plus goes and attacks here. So the first step is this. This is A, this is B, this is C, this is D. So simple now. This is C double bond O, OH2, because oxygen will donate electron to this H plus. This is an electrophile. This is nucleophilic. Why nucleophilic? Because oxygen has lone pair. Lone pair can donate. I have already told you this. Now, can oxygen bear a positive charge? No, it cannot. Why? Because oxygen is the most electronegative element. It can bear a negative charge. It can't bear a positive charge. Then what does it do? It will take away the electron from this carbon. So what is the intermediate you are going to get? The intermediate of this reaction is this OCH3 I already have. This is A, this is B, this is C, this is D. Am I right? So this is A, B, C, D. C, D, this is I have. Here you are going to get a positive charge. Water is removed. Am I right? Water is removed. So this is the intermediate, guys. This is the acylium carbocation. Sir, can it undergo any rearrangement? Why did it form this? Now I told you arynium carbocation cannot undergo, acylium carbocation cannot undergo rearrangement because this is resonance stabilized. That is the reason this has been separated out from the molecule to give water and this stable arynium carbocation. Now the next step is so simple. It goes and attacks this benzene ring. Sir, wherever it is giving rise to a stable ring. Let us see here. What happens if this attacks here? Let us see. This is the first carbon. If it attacks here, second, third, fourth, 5, 6, 7. 7-membered rings are not stable. You go here, you will get 8. I go here and check. 1, this is 2. If it attacks here, this would be 2. 1, 2, 3, 4, 5, 6-membered ring. So the product is this. Where do I write the product? I'll write here. The place isn't sufficient. So what do? I'll write the product here. I'll write the product here, guys. Just check. What do? How is the product there? This is what you have. This was OCH3. Right? This was ABCD. A, B, C, D. D is going to attack this benzene ring. No substituent. You won't want to check A, this is B, this is C, this is D. Cyclic rings are formed generally during Friedel-Crafts acylation and alkylation intramolecular reactions. Right? Some cases it may also result in 5-membered ring. You need not worry much about it. Generally 6-membered rings are stable. So this is how you have got the product. Do you have any option? No, options are not given. So this is how I have given this question. So hope you have enjoyed this session of intramolecular Friedel-Crafts reactions. So this is end of concept lecture 6. But guys, please wait a minute. Wait a few seconds. This is your homework. So this is the quiz for yourself. Please solve this problem. In the lecture number 7, I would be discussing this problem at the beginning of the lecture number 7. Please do solve this. Okay. So guys, this is the end of lecture number 6. We'll meet in the lecture number 7 with quiz yourself. Right. That's all we have from Teach Tiger. Thanks. Your Vamshi signing off.